Give me a guys. I'm still audible. Am I still
Yes, sir.
audible?
Yes, sir. Yes, sir.
I think my system has stuck. It's frozen. It's not working. Okay. I will just restart my system, है ना? And I will rejoin. Just give me a minute. Guys, I'm really sorry for that glitch. I need post permissions from. Hopefully it works right now. Yeah, please write ethers. So what are ethers? Ethers, they have two alkyl groups. attached on oxygen atom. Two alkyl groups attached on oxygen atom. So both of these alkyl groups may be same or may be different. That is why we generally show it as RO R dash. RO R dash. This is ether. So first of all, we will talk about the nomenclature here. So one more thing about ethers is that we see if I draw the complete structure with the shape and everything, so it will be something like this with two lone pair electrons here. So ether, it has lone pair electrons, and it is the oxygen atom of ether. It is electron rich species. It is a electron rich species. Okay. Now, when we look at ethers, then first of all, we will understand the nomenclature of ethers. Huh? First of all, understand the nomenclature of ethers. Please write. Nomenclature. So in nomenclature, let us suppose we have example that is CH3 bonded with oxygen, CH2 and CH3. Now, if I write the IUPAC name, then the IUPAC name will be, since it does not have any functional group. So we will see the method that we have is functional group, unsaturation, parent, and then substitute. We first of all identify functional group. So we don't have any functional group from the list of functional group. That is why we write E. There is no double bond or triple bond. That is why we write AN. Then the parent chain. So parent chain will be the longest carbon chain because we don't have functional group or unsaturation. Okay. So it will be two carbons like this. So it is going to be it. And what is the substituent? Substituent is this part, whatever is remaining after the identification of puff, parent unsaturation and functional group. So the substituent here is OCH3. So it will be methoxy. Meth means CH3, oxy means the oxygen that is present. So it is methoxy. Now this will be named as 1-methoxy methane. Now this is about IUPAC nomenclature. That means if they give you this question, they give you the structure and they ask you what is the IUPAC name, then you will write it like this. But whenever a questioner is making questions regarding ether, they want to ask you some reactions about ether. And this methoxymethane is one of the reactants. So they will never write methoxymethane. They generally write in terms of the common name. So the common name, it ends with ether because it is an ether, and the alkyl groups that are attached. So this alkyl group here, it is ethyl, and this alkyl group, it is methyl. So then the name becomes ethyl, methyl, ether. Ethyl, methyl, ether. For example, if you have two CH3 groups, oxygen, and then once again CH3. Now this is also methyl, this is also methyl. So we don't write methyl, methyl ether, rather we write dimethyl ether. Right? Dimethyl ether. There is another one which is very important. Please write the name. Di-tert butyl ether. Di-tert butyl ether. First of all, obviously, if it is ether, we will have oxygen with two different groups attached. We will have oxygen with two different groups attached. I'm talking about di-tert butyl ether. Now, what is di-tert butyl ether? Please remember, this is a carbon atom. Carbon atom that is connected to 3 CH3. That is why it is tertiary. This carbon atom is tertiary. And this whole fragment, it has 1, 2, 3, 4 carbon atoms. That is why it is tert butyl. It is tert butyl. Similarly, because it is now di-tert butyl, we will also have a CH3 carbon here, and it will be attached with 3 CH3s. Okay, so write the names and structure of these structures, and then we will move on to the method of preparation. Please write this down. These are some examples.
Excuse me, sir.
Yeah, Fadil, tell me.
Sorry to interrupt, sir. The first structure, the IUPAC name, shouldn't it be 1-methoxyethane?
It will be 1-methoxyethane. Yeah, thank you very much. ethane यहाँ पे एथ लिख के हमने वहाँ मीथेन कर दिया, my bad. 1-methoxyethane, correct. Okay, so in SPUF we generally go like this. Okay. By the way, have you seen this method, Fadil? SPUF?
Yes, sir. Yes, sir. I was there when you taught.
Yes, yes.
No, I watched the recording, sir.
So you have also watched the record. Right?
Yeah, yeah.
So, Rajita, you have not messaged me till now on WhatsApp. If you message me, I will send you the recordings now.
Okay, sir. I'll do that. I'll do that after the
You need
class.
after the class. After the class.
Okay, sir.
All of you wrote this, yes or no, please tell me.
Writing, sir.
Right. Okay. Right. Let me know once you're done. Susan, we have just started right now. Okay.
Okay, sir.
Please let me know once you're done writing.
Sir, done.
Whether this CS3 has lost place.
Sir,
Yeah, tell me.
sir, I didn't get the naming of the third structure.
Dimethyl ether.
Yes, sir. No, not dimethyl ether, the one after that.
Di third butyl. Okay. So I
Yeah,
guess
yeah.
the problem, di is not a problem. Ether is not a
No,
problem. Third
no.
butyl is the problem, right?
Yes, sir.
Just give me a second. 75309980007. Okay. Those
Sir, I know
who
how we
have,
got butyl.
you know how you got butyl.
Yes, sir,
So
because of the
actually,
carbon chain.
actually not carbon chain. Actually, you see, the carbon chain is 3 carbon, right? So this is actually about isomers. Okay. So हम चलिए बता ही देते हैं आप लोगों को, देखिए here guys. Butyl means 4 carbon atoms. Okay, all of you please don't write anything. Leave your pen aside and just enjoy. Okay, don't worry. Don't try to make notes or anything. Okay, don't try to make notes or anything. Just see here. If you have 4 carbon atoms, we are having 4 carbon atoms. Okay, and I hope all of you know that this is 4 carbon atoms, right? Yes or no? Yes, 4 carbon atoms. All of you understand this? Please tell
Yes,
me
sir.
yes or no. Yeah, all
Yes,
of
sir.
you. Rajita, Majid,
Yes, sir.
Fadil. Yeah, okay, fine. 4 carbon atoms.
Yes, sir.
So I can write the 4 carbon atoms in a different way also. I can write 1, 2, 3, and like this. Correct? Correct? Yes or no? Are you not speaking anything?
Yes,
Or
sir.
I can't. Lisa, you can't hear me. I'm speaking a lot of things. Aliza, I am speaking a lot of things. You can't hear me, I guess. Okay. Okay. Now, please see here, guys. Please see. Here in the first, we have two different types in which we can write the carbon atoms. In the first type, I can have two different ways of attaching any substituent. Please see. 1, 2, 3, 4 carbon atoms, and I can either attach it like this with this carbon atom, let us suppose any group, okay, and I can attach like this. There are only two possibilities. Correct? Yes or no? Please tell me.
Yes, sir.
Can all of you see that? Yes or no? Aliza, Deborah, Fadil. Now, if someone is saying, sir, there is two more possibilities, sir. We have 4 carbon atoms now. So I can write a group like this also. I will say, see, this and this is same. Can all of you see that both of these are same?
Yes,
If you
sir.
can't, then I will go further on.
Yes,
If you
sir.
can see that it is same, now. Chaliye. Now, and similarly, if someone is saying, sir, we can also write it this way. 1, 2, 3, and this carbon may, if I attach a group, then it is a different attachment. No, I will say it is same as the first one. I hope this
Yes,
is
sir.
clear for all of you.
Yes, sir.
We have exhausted all the possibilities for the first isomer of first 4 carbon atoms. Now, this is the most normal. And if I say I have 4 carbon atoms, then all of you will imagine this attachment, right? I say bromine is attached to a 4 carbon atom chain. So all of you will imagine this one. That is why it is known as normal, whatever group is there. Na? For example, if I write butyl here, sorry, bromo, Br. So I will say this is N-butyl bromide. So the point of attachment, N-butyl represents the point of attachment. Can all of you see that? Normal butyl. Now, if you see this particular carbon atom, this is 2-degree carbon atom, right? So if I attach Br here, then the common name will become, secondary butyl bromide. Got this? Yes or no? Please tell me. Make sense?
Yes, sir.
Okay. Now, similarly, if you look at this particular 4 carbon atoms. Now, 1 carbon atom is in the middle. Okay. 1 here, 2, 3, and 4. So here also we can have 2 different points of attachment. What are the points of attachment that we can have here is, first of all, please see. Br like this. Now this attachment or this attachment or this attachment, all of these are same. Can you see that?
Yes, sir. Yes, sir.
Right? Because all of these carbons are same, right? Now all of these are known as isobutyl bromide. It is known as isobutyl bromide. Oh, like the common name, they generally don't have much logic, but I try to search things up and see what is the logic behind ISO. And ISO is generally used when we have same. So ISO is used if I attach one carbon atom here and then Br here. And if you will cut this, you're going to cut it like this, then you will get same group CH3 and CH3. And that is why I think that is why they have named this as isobutyl. Iso means same. Okay. So this is isobutyl bromide. All of you got this? Another
Yes,
reason
sir.
would be, another reason of naming it ISO. I don't know what is the reason actually. Okay. Because you will, even in the literature, I could not find in any of the research papers why it is named as ISO. And what was the thinking there? Another would be, see, all of these 3 carbon atoms are same. That is why ISO. Maybe that is why ISO. Okay. But see, this is one of the point of attachment. The point of attachment is this one. So I will make it a green. And this is isobutyl bromide. Now there remains one point of attachment, that is with this middle carbon atom. If I attach a Br group here, and since this carbon atom, it is a 3-degree carbon, this will be tert butyl bromide. So if I have a group of 4 carbon atoms and it is attached to something with this 3-degree carbon, then this fragment is known as tert butyl. And whatever is attached, वो फिर बाद में आ जाएगा ना. If chlorine, chloride, है ना? If you have bromine, bromide. If you have OH, it will be alcohol, tert butyl alcohol. Got this? Yes or no, please, Sunny? Fadil?
Yes, sir. Yes, sir.
Okay. So now you understood why it is tert butyl.
Yes, sir. Yes.
Can you see that? Carbon, है ना? 3-degree carbon atom. Okay.
Yes, sir.
See, maybe you will, if you ask Learnivio, na, you please send me basics of organic chemistry. Then I have taught all of these things in the basics of organic chemistry chapter. I mean, not chapter, the revision classes. देखिए.
Yes, sir. I need to go. Yes, sir.
N-butyl, secondary butyl, isobutyl, tert butyl. In 3 carbon atoms, we'll have N-propyl or isopropyl. Point of attachment differs only. Hai? If this is the point of attachment, here this is the point of attachment. For 2 carbons, you won't have anything. In 5 carbon atoms, you can have N-pentyl, isopentyl, neopentyl. Okay, fine.
Yes.
Moving on to our method of preparation of ether. Please write the topic. MOP of ethers. Now, the first method of preparation is dehydration of alcohol. By the way, Father, you have my number?
Yes, sir.
Dehydration of alcohol. Now, this may seem something you have seen already. Dehydration, this phrase, dehydration of alcohol. Seen that. And in alcohols, when we dehydrated it using H2SO4 at high temperature. So let us say the example CH3. Then you have CH2 and OH. This is alcohol. And if I use H2SO4 at a high temperature, H2SO4 and temperature is, let us suppose 443 Kelvin. Then we get ethene, CH2, double bond, CH2, and elimination reaction happens here. So this is something that we have seen previously in the chapter when we were dealing with the chemical reactions of alcohol. Another dehydration can occur with H2SO4 at lower temperature. And the temperature that is given in the books is 413 Kelvin. Please don't write anything. Please listen because I'm going to change a few things. Okay. Please don't write. Leave your pen aside and please see. Now, when we react this with H2SO4 at 413 Kelvin, then we get CH3, CH2, O as it is. This hydrogen is replaced by one more alkyl group like this. CH2, CH3. So in this case, substitution reaction is happening. In this case, substitution reaction is happening. Okay. And here we got alkene. Here we got ether. Here we have got ether. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay. Please see. That means in general, what I was trying to say is, how will I remember the temperature? How will I remember? Should I write 413? Then I say, no, don't write 413. See this example. This is R, alkyl group, O, and then alkyl group R. So what I ask students is that you write 414. ROR, 414. So 414 is very similar to the ether's general formula. That is why you write 414. Don't remember 413 or something like that. Okay. Remember 414. Okay. If you want to write the reaction, but even if you don't write, just show the sign of heat. That will do the work. Now, please write. Next thing is ROH, general reaction ROH when it reacts with H2SO4. H2SO4 and you have 414 Kelvin, then in that case, you will get ether, RO, and the same alkyl group. This alkyl group, now, so this alkyl group will be attached on the either side of alcohol, ROR. Now, if same alkyl group is attached on either side of the oxygen atom, we call them symmetrical ether. We call them symmetrical ether. So please write ethers having same alkyl group on either side of oxygen atom called symmetrical ether. Is called symmetrical ether. Now, please write, if you have not written this, please write. Raise your hand if you're done. You can raise, if you are on a laptop, you can raise your hand by pressing Control Y. Control Y नहीं. Control Y से नहीं होता है, Alt Y. तो ये होता था पहले, पता नहीं क्या हो गया. हाँ, Alt Y. If you press Alt Y, you can raise your hand. Okay, Rajita is done. Raise your hand if you're done, guys. Waiting for Aliza, Deborah. Aliza, Deborah, Fadil, and Majid. Aliza, can you hear me now?
Yes, sir.
Okay, ये प्रॉब्लम पहले भी हुई थी ना शायद एक बार.
Yes, sir.
क्या हो गया सिस्टम को? Aliza and Fadil waiting for you guys. I think you must have written till here at least. Okay, all
Yes,
of you
sir.
please write with me. Dehydration of alcohol. Dehydration of alcohol. Dehydration of alcohol with concentrated H2SO4 at 413 Kelvin gives symmetrical ethers. Now we will see some problems. CH3OH. H2SO4, 414 Kelvin. What is the alkyl group here? In the alcohol, what is the alkyl group? In CH3OH, what is the alkyl group here? Guys, what happened? What about others? Rajita, Fadil, Aliza, Majid, Hussain, tell me. Alkyl group. CH3. All of you can identify this? Yes or no? Please tell me.
Yes.
All of you can identify now. CH3 is the
Yes, sir.
alkyl group, right? So write the product. And oxygen atom, on either side of oxygen atom, you will have CH3 group. Complete the products. And then, for example, if you have something like this, then on either side of oxygen atom, what is the alkyl group? You will write that. Count the number of carbon atoms and then write the product. Send the answer on my WhatsApp. You will send the answers on my WhatsApp. For example, you have something like this. Don't write this reaction. Okay, don't write this. You write simple reactions only, because that will be asked. Okay, so these two, please write it, send the answer on my WhatsApp. I'm going to give you 3 minutes. If you don't have my WhatsApp number, I'm again writing it down. Please note it. 17530998007. I've got some answers, I think. Aliza has sent me. Okay, let us see. That works. That works. Correct, Aliza. First one, I hope all of you have written it correctly. CS3.
Yes, sir.
Someone sent me on chat, sir. Can I get your phone number? Hussain, are you not looking at the screen? This is my number. This is my number. A very easy way to WhatsApp any number is that all of you must have some group in which only you are present or saved messages kind of thing. To type the number there and send it. Once you send a WhatsApp number on any chat, it will appear in blue. You press on that blue number. It will say searching on WhatsApp, and then it will come options chat with plus 91753099807. Okay. So I have seen sometimes what happens if it is a like international number, like you're in Saudi or Dubai or Kuwait or somewhere else. And I'm in India. WhatsApp doesn't pick it up very quickly if you save in your contact and then try to search on WhatsApp. So many times, yeah, Rajita, I got okay. Yes, Rajita. Okay, so many times students complain that, sir, I can't find your number on WhatsApp. Okay. So send it somewhere to your father's number or mother's number and then press on that blue number. Okay, Rajita, yeah, correct. Very good, Rajita. So you're comfortable with the bond line structures, I guess, right, Rajita?
Yes, sir.
Okay, yes. Hussain. Okay, fine. Okay, so time is over. Please send the answers, guys. So let me add your numbers right now. Mir, that is 12, C4, 23, 24. Oh, okay. So I see your problem. Okay, so you're not comfortable with the bond line structures, right? Mir Hussain.
Yes, sir.
Okay, fine. So I will send you a PDF. You will read it and do all the problems in that PDF. Okay.
Okay, sir.
Okay. Right now you can write it this way, na? Two carbon atoms, then oxygen, and then again 2 carbon atoms. For here, 1, 2, 3 carbon atoms, 1, 2, 3 carbon atoms, then oxygen, and then again 1 carbon, 2 carbon, 3 carbon, 1 carbon, 2 carbon, 3 carbon. Okay. Let me just send it to you right now itself. Bond line. Okay, I have sent you a PDF. Please go through it. Somebody else? Deborah. Okay. And Deborah, you send the answers once I have written the answers. Cheating करते हैं आप. Cheating. Okay, please see here, guys. Right, mechanism. This mechanism is important. They can ask you this mechanism in the board examination, and previously they have asked this mechanism. Okay, so please write mechanism of which reaction? Mechanism of dehydration of ethanol, CH3, CH2 bonded to OH, H2SO4 and 413 Kelvin. So they will ask you write the mechanism of dehydration of alcohol to form ethers. So you'll write this mechanism, okay? CH2, this is not mechanism, this is the reaction actually. CH2 and then CH3, okay? Now, first of all, the first step will be protonation of alcohol. Protonation of alcohol. So what happens in protonation, please see, I'm writing this in bond line structure, 1 carbon, 2 carbon, and then O, which is bonded with H. Oxygen atom has lone pair electrons. And from H2SO4, please don't write anything. Try to understand what is happening, and then you can write on your own. Okay, by the name itself, you will understand what step is involving. So with H2SO4, I will get a lot of H plus ion. So the oxygen atom will attack on the H plus ion like this, leading to the protonation of alcohol. I'll have 2 carbon atoms like this, oxygen with 2 hydrogens like this. And this oxygen will have a positive charge. So it has attacked with 1 lone pair. So 1 lone pair is still there. And if you look at the oxygen atom right now, please don't write anything. Try to understand. So you have 1 bond, 2 bond, 3 bonds, and a lone pair electron. So the oxygen atom, it is having 3 bonds, meaning 6 electron, and 1 lone pair, it means 2 more electrons. So 6 plus 2, that means it is having 8 electron. Even though positive charge is present on oxygen atom, please, this is very important. Even though positive charge is present on the oxygen atom, it is not electron deficient. It already has 8 electrons. You cannot attack the oxygen atom to make bond or do something. It is already having 8 electrons, but it has gained a formal charge. That is just formal. It is not a pure charge that is present. Please see next, protonation of alcohol. After that, second point is the attack of nucleophile. Attack of nucleophile. So nucleophile, it is a electron-rich species. An electron-rich species is nothing but alcohol itself. Now the alcohol oxygen atom is what it is, electron-rich. So it will attack on the protonated alcohol. So protonated alcohol is having this type of structure with the positive charge on oxygen atom. Now it seems a very good thing to attack this lone pair to the oxygen atom because oxygen is having positive charge, but that cannot happen. Oxygen cannot accept any more electron because it is having already 8 electrons. So what will happen? This oxygen atom, it is attached with this carbon atom, and it is pulling electron density from the carbon atom because oxygen is electronegative. And this carbon will get a delta positive charge, and the oxygen atom, it is going to attack this carbon atom. As soon as it attacks the carbon atom, this bond is broken, and the electron of this bond goes to the oxygen atom and neutralizes it. So first of all, what is going to happen? I will get H2O from here. This fragment will leave off. It will break away to form H2O. And this one, it is now oxygen that was already bonded to hydrogen. Now it is bonded to this carbon atom, the red carbon atom. And this red carbon atom, it is further bonded to this carbon atom. So this red carbon atom is bonded like this now. So these 2 carbon atoms are here. Now this again, oxygen gets a positive charge. Plus we will get H2O, and that is why the name comes dehydration. So what is being removed? Dehydration of alcohol. So we can see, yeah, okay, dehydration is taking place, water has been removed. In the third step, what is going to happen? Deprotonation. Deprotonation. Now, going by your NCERT, you can directly write it like this. The H positive, and here you have positive charge, H, and a positive charge on the oxygen atom. So what will happen? The H will lose the electron to oxygen atom, deprotonating it and neutralizing the oxygen atom also, like this. And plus you will get H plus. So H plus was used as a catalyst. So H plus was used here, and it has been produced once again. But sir, actually what is happening if you ask me? So please see, H2SO4 was present. H2SO4 will split up into H positive and HSO3 negative. This HSO3 negative, it is going to attack on the hydrogen atom. It is one of the possibilities I'm saying. HSO3 negative attacks on the hydrogen atom. One, this can happen. Another thing that can happen is another alcohol molecule can attack this hydrogen atom and then again back to first step, protonation of alcohol. Okay, so this alcohol is now getting protonated. So there are multiple things that can happen to this particular H, which is attached on the oxygen with positive charge. Okay, so for deprotonation, you will write only this much. So this is what has been given to NCERT, given by NCERT to you guys, and this is what you have to write. There is one confusion that can happen after the class is done, but I have cleared that also, that oxygen, even though it has a positive charge, it is not electron deficient, it is electron complete electron. 8 electrons are already there. You don't need to add more electrons here. Please write this down. Let me know if you're done. Raise your hand once you're done. Raise your hand if you're done writing. Deborah is done. Waiting for Aliza, Fadil, Hussain, Rajita, and Majid. Waiting for Aliza, Fadil, Hussain, Rajita, and Majid. Please raise your hand once you are done. Majid, done? Okay. Now, write some remarks. Write remarks. Number 1, it occurs via SN2 mechanism. SN2 mechanism. Therefore, rate of reaction. If I talk about how fast a reaction will go, then methyl alcohol is fastest. Then 1 degree, then 2 degree, and then 3 degree. Generally, 3 degree, they don't, if you see 3 degree, they tend to form alkenes and go under elimination. Because you can see that what is happening. The same conditions, you can form alkene as well as ether. So if you want to do substitution, that means ethers, you have to take 1 degree or methyl alcohol. 2 degree and 3 degree, they form a significant amount of alkene. Please write 2 degree and 3 degree alcohol gives significant amount of alkene, give significant amount of alkene with ether. You will get ether, but you'll also get a significant amount of alkene. So if you want only ether, then you should not use a 2 degree or 3 degree alcohol. Okay, please write with ether, as they are the 2 degree and 3 degree alcohol, they are more hindered. They are more hindered. Hence, this method is not suitable for the formation of symmetrical ethers. For the formation of symmetrical ethers, we using 2 degree and 3 degree alcohols. Okay. The third point. This method is not suitable for the preparation of unsymmetrical ethers. Because it would require 2 different alcohol. It would require 2 different alcohol and lead to formation of mixture of ethers. Difficult to separate. Okay, so I hope second point, you can easily understand the second point. 2 degree and 3 degree alcohols, they will be obviously more hindered. And that is why they will give a significant amount of alkene. Elimination is suitable when you have hindered molecules, when you have hindered substrate. Let us understand the third point, why it is not suitable for the preparation of unsymmetrical ethers. An example of unsymmetrical ether will be 2 carbon atoms on one side of oxygen and 1 carbon atom on the other side of oxygen, like this. Now, this fragment, the 2 carbon fragment of the ether should be coming from an alcohol like this, alcohol of 2 carbon. Similarly, this 1 carbon alkyl group will be coming from an alcohol of CH3OH. Everything makes sense till here? Yes or no? Please tell me. I want to make an unsymmetrical ether, right? Fadil, Hussain,
Yes,
Aliza,
sir.
Deborah, I want to make an unsymmetrical ether. I've taken an example. So if I have unsymmetrical ether, I will be having different alkyl group on the either side of oxygen. That is why I will be needing 2 different alcohol. Rachita, Deborah, Aliza, got it? Yes or no?
Yes, sir.
Yes. Now let us try to react this. Now, please see, we have ethanol and methanol. What do we have? We have ethanol and methanol. Now, please try to understand. Don't write anything. If you're writing something, please leave your pen aside. Don't even touch your pen. Okay. Aram se relax and listen. If I have a container in which I have ethyl alcohol as well as methyl alcohol, then what will happen? Some of the ethyl alcohol will be so far away from the methyl alcohol, they will never ever meet the methyl alcohol. They will never meet the methyl alcohol. Before meeting any methyl alcohol, they will meet another ethyl alcohol and they will react with the ethyl alcohol itself, leading to formation of an ether like this. Correct, guys? There will be some ethyl alcohol. Now, there are plenty of ethyl alcohols in the container. You will have at least 1 mole. 1 mole means billion, 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 billion. 6 times billions, and then you will get 1 mole. So that many molecules are there. So for sure, there will be some ethyl alcohol which will never meet the methyl alcohol, and they will react with themselves, forming diethyl ether. Agreed? Yes or no? Please tell me. Make sense? Rajita, Fadil,
Yes,
Majid,
sir.
Deborah, Alina. Make sense?
Yes, sir.
Okay. Similarly, there will be certain methyl alcohols that will never meet the ethyl alcohol and they will react with themselves, leading to formation of dimethyl alcohol. Now, there will be a few ethyl alcohol and methyl alcohol which will meet each other, and then they will form the required ether. Then they will form the required ether. Now, can you see that 2 of the 3 products are waste? I did not even want these products, and I did not want this. I wanted only this product, and I'm like, what bad kind of yield is this? That 2/3 of my reaction is completely wasted. Another thing is that this particular, please listen, don't write anything. This particular ether can be used only if I can separate it from the mixture of these 3. Only if I can separate from the mixture of these 3, and the separation of this methyl ether will be very difficult, because all of these ethers, they will have similar property. They will have similar property. Property means their boiling point will be similar. That is why I cannot use distillation. Their polarity will be similar. That is why we cannot use chromatography. So the separation of these 3 ethers, which are very similar in the number of carbon atoms and their polarity. So obviously we will not be able to separate them easily. They can be separated. I'm not saying they cannot be separated. They can be separated. But whatever time I was saving, whatever money I was saving by reacting the simple molecules with a simple reagent H2SO4 that is also available in the 10th class lab, we are not using any high chemical, right? I'm not using any expensive chemical. But I wanted profit. That is why I was not using any expensive chemical. But what is the cost? The cost is in separation now. That is why this method, it is not suitable for the preparation of unsymmetrical ethers. Why? Because it would lead to the formation of mixtures of ether which are difficult to separate. Is this crystal clear? Yes or no? Please tell me. Rajita, Majid, Fadil, Deborah, Alina.
Yes, sir.
Okay. Write this down if you have not written. Let me know once you're done by raising your hand. Now, this particular question was asked in the board examination, and the wording of the question was very interesting. Okay, I'm just deleting this arrows here like this. Okay, so the wording of the question was, let me get it in a red color. Can you explain why is bimolecular dehydration of vinylic acid? Dehydration is not appropriate for the preparation of ethyl. Preparation, I messed up. Preparation of ethyl methyl ether. They're not directly asking why. See, they're asking why bimolecular dehydration of is not appropriate. Bimolecular means you are using 2 different molecules. Okay, so this is a question that was asked in post examination, and you have to write this particular answer. I mean, the base, like the simple answer or one-liner would be from here. It leads to formation of mixture of ethers difficult to separate. That's it. Okay, that would have been the answer. Can explain why bimolecular dehydration is not appropriate for the preparation of ethyl methyl ether. Achha, now tell me all of you guys, if you did not see this question, and if I did not tell you about this question, but you have learned this topic, right? Yes or no? You have learned this topic,
Yes, sir.
but I did not tell you about this question. Would you be able to attempt this question? Tell me. Fadil, Hussain, Rajit. Now you can attempt because I've shown you the relationship.
Yes, sir. Yes, sir.
It would be difficult, right? Now you can write it. But if I did not tell you that is this question is related to this particular topic, it would have been very difficult, I assume, to understand what is bimolecular dehydration. ये तो कोई पढ़ाया ही नहीं. Okay, so
Yes,
that is
sir.
why it is very important to practice questions. It is very important to practice questions. Okay, so when you practice question, you will see the wordings may be different for the same topic or the same point. The question can be asked in many different ways. Okay, chaliye. I hope everyone is done writing. Can I move on?
Yes, sir.
Okay, right next. The second method of preparation from alkyl halides. This is also known as Williamson ether synthesis. Williamson ether synthesis. This is very, very, very important. If you are doing the chapter alcohol, phenols, and ethers, and you want to do one topic, do this topic. If you have time to do only one topic, do this topic, Williamson ether synthesis, in the complete chapter alcohol, phenols, and ethers. Okay. Now, this has been one of the favorite topics of CBSE to give questions from in this chapter, particular chapter. See, alcohol, phenol, and ether. So ether is the easiest part. Why? Because I mean, method of preparation, only two method of preparation. Chemical reaction of ethers, only one chemical reaction of ether. Okay. And the CBSE, they have to give at least one question from ether. So if you are learning alcohol, phenol, and ether chapter, and you want to learn a certain, like one part, please do ethers, revise ethers in test, in board examination. If you are ill, something happened, you don't want to revise the complete thing, at least revise ethers. Okay, at least revise the ether part. Please write here from alkyl halides. Now, in this, you will write the statement, and then you will see the reaction, what is happening. Please write when haloalkene is treated with. When haloalkene is treated with suitable sodium alkoxide and SN2 reaction takes place, and SN2 reaction takes place forming corresponding ether. Write this down, then we will explain what is happening. Okay, I hope everyone has written. Now please see. Haloalkene is treated with suitable sodium alkoxide. The first pitfall. पहला गड्ढा आपके लिए, पहला हादसा सोडियम एल्कोक्साइड. क्या है ये? Please see. If you react alcohol with sodium, not sodium hydroxide, only sodium, you will get sodium alkoxide, RONA. This is sodium alkoxide. Plus you get H2 gas. That is different thing. Okay. थोड़ा अगर याद हो आपको क्लास 10th की चीजें, so reaction of metal with acid, it gives salt and hydrogen gas. salt and hydrogen gas. How to detect hydrogen gas? Existence of hydrogen gas. How to detect? Burning candle. If you bring burning candle near the hydrogen gas, then it will give a pop sound. Pop sound. कुछ याद आ रहा नहीं याद आ रहा? हाँ जी.
Yes, sir.
याद आ रहा है कुछ ठीक है. Sodium. This is alkoxide. No, so obviously I hope you can replace the R group with CH3. You will get CH3RONA. Now when this RONA, sodium alkoxide, it reacts with haloalkane, which is RX. I've written R dash because this R and this R may or may not. It can be different also. That is why they have written it different. So this alkyl group will have a delta positive charge because it is attached with an electronegative element halogen. So halogen is pulling electrons from the alkyl group and the alkyl group is getting a delta positive charge. Then this oxygen atom with its lone pair will attack on the R dash, leading to formation of R, O, R dash plus NaX. For example, please see, if I have alcohol like this, in the first step, I will be reacting it with Na. In the second step, if I react this with CH3Br, then what I will get? First of all, I will get the same thing. This thing will be still the same. Let me get this in red, and this thing in blue. Okay. So please see. This red part will be as it is O. And then this CH3 from the alkyl group, sorry, alkyl halide will be attached like this. All of you understood what is happening, yes or no?
Yes, sir.
Okay. Sometimes you may see something like this also. Please see. Sodium, you have alkoxide. It is being treated with, let us suppose, Br like this. Now here you can see that, here you can see this till oxygen atom will be the same. 2 carbon atoms, oxygen will be the same. And then the alkyl group of haloalkane. So that is 2 carbon atom once again. So this will be also 2 carbon atoms. So this fragment, it is coming from the sodium alkoxide. This fragment, it is coming from the haloalkane. Please write another example. ONA plus 2 carbon atoms Br. Now what will happen? See, till oxygen, it will be the same. I am saying this so many times. Till oxygen, it will be the same. And then here you have 2 carbon atoms. 2 carbon atoms, 1 carbon atom like this, second carbon atom like this. Okay, or you can write it like this. OC2H5. You can also have something like this. All of you understood this? Yes or no, please tell me.
Yes, sir.
Yes, sir.
Please write this down. All of you done? Can we write some remarks? अच्छा remarks से पहले एक काम करते हैं. Let us write at least one question ना. Let us at least write one question. Let us at least write one question. One question. One question. One question. No, no, not like this. Cyclohexane. Send the answers on my WhatsApp. Send the answer on my WhatsApp. So sent me. Yes, Aliza. Aliza BR ठीक से लिखिए ना.
Sorry, sir.
Others, please send the answer. Deborah, Fadil, Majid, Majid चलिए कहाँ चलिए? Hussain and Rajita. Fadil has sent. Yeah, Fadil correct. One carbon, two carbon. Yeah, fine, very good. One more answer, Deborah. BR will not be there, na Deborah? Why will BR be there? See, did we write anywhere BR? BR नहीं रहेगा ना? Only the alkyne group will be present. Please correct it. One carbon, two carbon. Write a few remarks. Hussain, I'm saying you like very seriously, don't miss any more classes, okay? Don't miss any more classes. You have missed already too many classes now. एक तो late आए हैं आप, ठीक है? चलिए, write the first point here. Williamson ether synthesis is an SN2 reaction where alkoxide is nucleophile. It is the one which is attacking. And the haloalkane Rx is substrate. It is being attacked on. Therefore, the haloalkane should be less hindered. Okay. Next point. Please write. This is very important. To form unsymmetrical ether. To form unsymmetrical ether, 1 degree alkyl halides should be used preferably. So when you are making unsymmetrical ether, now you will see some questions related to it, that you have been given unsymmetrical ether and they're asking what are the reactants you will use to make this ether. So whenever you are making unsymmetrical ether, try to have the alkyl halide as 1 degree. Try to have the alkyl halide as 1 degree. Why? This right next. Usage of 2 degree and 3 degree leads to the formation of alkene as they are more hindered. As they are more hindered. You can see, for example, if you want to make something like this. Okay, so see, the alpha carbon are the carbons which are attached to the oxygen atom. So this is an alpha carbon and this is an alpha carbon, right? So whenever you have been given an ether and asked to write the reactants, how to make this particular ether, then you write the degree of both the alpha carbon. So this is the first one, this is the second one. Rajita, can you tell me what is the degree of this this first carbon atom? 1 degree, 2 degree, or 3 degree?
2 degree.
This 2 degree. And this second carbon, it is
1 degree.
1 degree. Very good. Okay. So this is the first thing that you are going to do. You are going to identify the degree of 1 degree, degree of the alpha carbons. Now, as soon as you see a 1 degree, this will be coming from Rx, right? And this portion will be coming from alkoxide, RONA. Correct, guys? Yes or no? Please tell me. That's what it is written here. Na? To form unsymmetric ether, 1 degree alkyl halides should be used preferably. That is why the reaction that you can have is ONA plus 1, 2 carbon atoms, Br. This is going to give you O and then CH2 and CH3. Understood this? Yes or no? Please tell me. All of you got this? Rajita, Mir, Aliza, Deborah. Fadil kahan chale gaye? Fadil, she got disconnected. Yes, Rajita, Aliza, got this? Yes or no? Yes, now. Okay, please let me know if you have any doubts. Okay, and please like do these type of things. I mean, circle. This will be Rx. This is 1 degree. Until this is known as working on problems. Okay, so working on problem, it happens on the notebook itself. Okay, so whatever you are thinking, try to, I mean, represent it on your notebook. Then you will gain a clarity on your understanding, and then also you will get doubts on your understanding. Okay, so that then you can clear those doubts. जब भी आप सोच रहे हैं किसी सवाल के बारे में ना, तब ट्राई कीजिए कि उसको पेन डाउन करें, रिप्रेजेंट करें पेपर में, क्या सोच रहे हैं, ठीक है? जैसे 1 डिग्री है, ये 2 डिग्री है, सोचेंगे आप लेकिन लिखते नहीं है बच्चे, तो उसमें बहुत मिस्टेक होती है, ठीक है? Aliza, you are saying something?
No. No, sir.
Okay. Chaliye. Please see next. Let us suppose I have to make an alkoxybenzene. What is the meaning of alkoxybenzene? Please see. Benzene ring with the oxygen atom and then R. Now there are two possibilities of making. There are two possibilities. I can either use sodium phenoxide, that means ONA, and any alkyl halide Rx. Another possibility is that I can use haloarine, Na. Okay, and RONA. Now, please see in both the cases what should happen. In both the cases, as you can see in the previous cases also, this bond is broken. So here this bond will break, and in this case, this bond should be broken. Okay. And those who have done haloalkane, halorine a bit, and especially if they have done halorine, they would remember that this particular bond, it is not easily broken. Why? Because resonance can happen here and it has partial double bond character. It has partial double bond character. And if you cannot break this bond, then this is not going to give you anything. So this reaction won't happen. In order to make alkoxybenzene, you have to use phenoxide and what? And haloalkene. Okay, so please write alkoxybenzene cannot be prepared using haloarene because haloarenes don't show SN, है ना? Until this bond